Okay, let's jump in. We're doing a deep dive today on a really interesting piece of hardware. It's all about providing real-time oversight for those critical places where, you just can't afford any surprises.
Hmm.
We're looking at the NTI E-1WP-D environment monitoring system. Our mission, really, is to see how this one little box can be the remote eyes and ears for your entire setup.
And what's so fascinating right off the bat is how it handles two huge threat vectors at once. It's not just about environmental stuff like temperature or humidity.
Right.
It's also monitoring physical security, things like power failure, smoke, even if a door has been open.
And the alerts are what really sell it for me. It's not just an email that might get lost in your inbox. It makes sure you get the message.
Yeah.
It can be a web page, an SNMP trap for your main dashboard, or, and this is key, an SMS message.
Which guarantees you see it even if you're nowhere near a computer. So let's talk about the core tech. It all runs on the one-wire sensor interface.
Okay, what does that mean in simple terms?
It means efficiency. It massively simplifies the wiring. You can run a whole array of sensors daisy-chained together with really standard connectors.
And the scale of that array is pretty impressive. I was looking at the numbers. You can connect up to 24 single reading sensors.
24, yeah.
Things like basic temperature probes, split across its two ports. That's a huge number for a device this size.
It is, but here's the nuance. It's not just about that raw number, 24. It's about how you use that capacity.
What do you mean?
Well, you can also use more complex combination sensors, like the ones that do temperature, humidity, and dew point all in one.
Oh.
But each one of those counts as 3 single readings against your total. So you have this resource pool, and you can configure it however you need.
And the cable length. I saw this and had to double check. 600 feet per connector.
600 feet. It's designed for that kind of industrial scale.
That's a massive run.
Mhm.
Does it actually stay reliable and accurate that far out with a bunch of sensors chained together?
It does, absolutely. And what helps is that the sensors are hot pluggable and they're detected automatically.
So no fiddly setup.
Exactly. You just plug it in and it works, even over those really long distances.
Okay, so that's the hardware. Let's pivot to the software side. Because I think the real intelligence is in the networking. This thing operates on its own over a standard Ethernet connection.
Right. It's an IoT device.
But it also acts as a network monitor itself. It can ping up to 4 other devices on your network.
And send an alert if one of them stops responding. So it's watching your network gear too.
And that intelligence extends to the alerts. I think anyone who's ever been buried in notifications will appreciate this. You can set up 32 standard alerts, which is great. But the real game changer is the smart alert.
Yes, this is the best feature. It prevents that alert fatigue you're talking about.
How does it work?
You can combine conditions. So instead of 2 separate alerts, you can create one that only triggers if, say, high temperature and main power lost happen at the same time.
Which tells you it's a much more serious problem.
Exactly. It adds context.
And speaking of power loss, for a system like this, redundancy is non-negotiable.
Of course, the base model, the E1W, already has dual DC redundancy, so it can fail over automatically.
But the E-1WP model goes even further. We're talking triple power redundancy.
That's right. You get the 2 separate DC power inputs.
Plus power over Ethernet.
Plus PoE. So if you're using PoE, you have layers of protection. It's just an incredible amount of resilience for your monitoring system itself.
And it seems to integrate pretty well with existing systems.
Oh, absolutely. It plays nicely with standard SNMP management software, things like Nagios that a lot of IT departments already use. And it supports all the modern protocols you'd expect. HTTP, HTTPS, strong AES encryption, even a JSON REST API for custom integrations.
So when you put it all together, who is this for?
I mean, the applications are pretty broad. It's perfect for IT infrastructure, obviously, server rooms, network closets, but also things like cold storage or freezers where a temperature change could be disastrous. Basically, any unattended area that needs precise oversight.
So here's the final thought I want to leave you with. When you look at what this single, pretty low-cost system can do with the smart alerts, the massive sensor capacity, and that triple power redundancy, you have to ask, what should the minimum standard be for all business-critical areas today? How can we still be relying on older systems that only tell you about one problem at a time when we know that true disasters are usually a combination of failures?